All right, so let's move on then. We already saw this. This is really just a fragment, and I'm going to use it in order to point out some ways in which BFO, the BFO way of looking at things can help you do a better job of building an ontology, I think. Now let's just reflect for a minute on the background to this ontology effort. So the Mars mission involves a number of, and we're talking now about the Mars mission on the level of systems engineering. It involves a number of what we can call submissions, the projects, for instance. And these submissions have goals, they have requirements, they have leaders, people who are in charge of executing the project. And they have people who are in charge of sub-projects within the project. And one big focus of the group who have been creating this ontology design has been to understand the social organizational connections between all of these projects and sub-projects, and the goals of the objectives of the projects, how they relate to the mission and so forth. In other words, they've been interested in institutional, organizational aspects of large cyber physical stroke social systems. Now let me just describe what the all-sum rule is. Let's suppose that you want to say that brain part of head. You might want to say that, for instance, in an anatomy ontology. And an anatomy ontology, or the anatomy ontology that people most commonly use, is called the FMA, the Foundational Model of Anatomy. The Foundational Model of Anatomy is based on human, but it applies to all mammals, with very few exceptions, because the anatomy of mammals and the anatomy of other mammals and the anatomy of humans are very, very similar. And it's designed to be an ontology of normal humans. So every normal human has exactly 32 teeth and 2 kidneys and so on. Now, given that framework, we make the assertion, brain part of head. And here the assertion means that every single brain is part of some head. Now, that is satisfying the all-sum rule. Every ontology, according to the standard operating procedures that we defend, should only contain relations which satisfy the all-sum rule. So if you want to say A stands in relation R to P, for instance, A to B, so A is adjacent to B, or A includes B as part, or A is part of B, or A is descended from B, then you can only make that assertion in the ontology if it satisfies the all-sum rule. Now, why do we say this? Because ontologies are not interested in instances. They're not interested in how things happen in specific areas or in specific communities. They're interested in the meanings of the words. And those meanings are the same everywhere. And those meanings are captured by capturing universal relations, in other words, relations satisfying the all-sum rule, linking the words together. So, brain, part of head. Body includes, or body has part, leg. Thigh adjacent to knee, and so on. All of these are all-sum rules. And if you find an ontology which does not follow the all-sum rule, it's probably making a mistake. Now, the question is the all-sum rule satisfied here? Now, it's satisfied by component. Every component presents some interface. If it's a component of a larger thing, it has to interface with other parts of the thing, otherwise it's not a component. So that's all-sum, that satisfies. Some of you look confused, so am I not being clear here? So the component, if it's a component, has to be connected to the rest of the machine or whatever it might be, and the connection is called an interface.
State the rule.
Yeah, the rule says if A stands in the relation R to B in an ontology, then it must be the case that every instance of A stands in that R relation to some instance of B.
Say it one more time.
Yes.
If A stands in R to B, then every instance of A has to stand in this R relation to some instance of B. So if you put brain part of head in your ontology, it has to be the case that in living, healthy organisms, every brain is part of some head. And it is. Every brain is part of some head. Now the gene ontology, for instance, did not get that right. The first versions of the gene ontology had a really incoherent account of how relations work. And that was one of the first ways in which they realized that I had something to say to them that would be useful, because I showed them how to define part of, or anyway, how to make it satisfy a necessary rule. Yeah, a microphone.
So that makes sense, but I'm looking at it from jumping a step ahead in terms of application. So the ontology is going to interface with the database, which is going to join other databases together. What do you do with instances? Because
so,
it would break the rule.
Something
had to have two legs.
Right. So the FMA was created as a basis for doing ontology of anatomy. Now, there are very, very many anatomical defects. There are missing kidneys, missing teeth. There aren't actually any missing teeth, they're all missing. But there are many people who do not have 32 teeth. But if you were to build an anatomy ontology in which you would account for all the defects and all the normal cases, the ontology would be unmanageably huge. In fact, the healthy anatomy is already huge, but it's manageable. And so what the designers of the FMA decided to do was to create what they call a canonical anatomy ontology for the normal case, and then define what they call instance anatomies for specific cases where there is departure from the normal case. So for instance, somebody with 3 breasts is defined as somebody with 2 breasts, i.e. normal, plus 1 extra breast. And you can say that because you have the word breast already in the FMA. And this turns out to be the only serviceable way of approaching the problem of anatomy, because anatomy is such a difficult domain where so many divergences from the normal occur. In fact, we're all somewhere divergent from the normal, even those of us who have 32 teeth. So the way you deal with instances is to use the terminology of the normal, but use some deviates from relations. And even then, you can have an ontology which will satisfy the all-sum rule. Everybody who deviates from the 2 breast rule by having either too many or too few breasts, well, I'm not sure how it would go, but you can build an all-sum rule for that too. So in other words, there is a canonical way of deviating from the norm. There is canonical diabetes. And then there are various strange kinds of diabetes. And that you can build an ontology for canonical diabetes in which you satisfy the all-sum rule. And people have done that. Any more? Okay, so this satisfies the all-sum rule for component presents interface. It satisfies the all-sum rule for mission deploys component. Every mission, at this level anyway, is going to be deploying some equipment. That's what the whole thing is about. It's about missions like the Mars mission. And every mission pursues some objective. It would be a disappointing mission that didn't have an objective. So there we have 3 relations which satisfy the all-sum rule. But I question whether this satisfies the all-sum rule. Namely, every component performs some function The reason is that there are many failed missions, and the many pieces of equipment lying around in military warehouses that never ever saw the light of day. They're full of components, but none of those components ever did anything. They just sit there until they rust away. So it's not true that every component performs some function. It may be that every component has some function, if you're lucky, because you don't build a component unless you have some function in mind, but whether it ever gets to perform is another matter. And it is just a matter of fact that even the most well provenance designed tested component may never actually perform. And now similarly, there are going to be many projects in a large military mission which never execute the mission because their projects fail. The mission may still succeed, but whether a project executes is, I think, just as problematic as whether every component performs. And now finally we have requirement specifies component. Now that would mean that all the requirements for the Mars mission were requirements for components. Now there are two ways in which that might be true, if it really did satisfy the all-sum rule. One way is that the word requirement really means component requirement, and then there is another word which should probably be called requirement, which is more general, because there are other things which need requirements. Training, training institutions or training programs have requirements. Landing sites have requirements. Launch sites have requirements. And they're not components in the usual sense of the word component. And that might be the other way you solve the problem. You say, well, by component, I mean anything that could have a requirement. Then you would be satisfying the all-sum rule, but again, you would be using a term, component, which is going to be used by nearly everybody else to mean part of a machine or something like that. And you're using it to mean field in a desert where you might launch a Mars satellite from. Yes?
So I have a reaction to that says, can I be building what I'll call an ontology framed by intentionality, as opposed to realization of the real world?
Yes, good. So there are two questions here. So this way of formulating it fits very well with what the authors had in mind. So they know what they're doing. And I'm criticizing them from a perspective, an outsider's perspective, saying, this may be all very well for your group, but as soon as you start talking to other people, they will have problems understanding what you mean by component. And the whole point of the ontology is to enable that kind of exchange, not just between computers and computers, but between humans and humans. But the second point is, how do you deal with what the component should be doing rather than what the component is doing? And as you know much better than I, every engineered artifact has the specification on the tin of what it should be doing, but then when you put it into the field, it almost certainly doesn't realize that particular specification. Now, in Kubrick, we have actually, or the Kubrick people who are working on the Common Core ontology have actually addressed that problem. So they have, I won't say they've doubled everything up, but they have found a way of doing justice both to the requirements as specified and to the actual capabilities of the machines and so forth in question. So we can do that, and I will show you how BFO does it more generally at a later stage. So basically we distinguish between processes in general and planned processes as a child of process. And it's the planned process which always goes right. All right, so
Barry, I have a question. Though the rule is very clear, the same argument that you presented for validating the project doesn't satisfy
Yeah.
the rule. I guess you could make it for objective. You can have a mission with lots of objectives, but not all of those necessarily are going to be pursued.
Okay, but remember, the all sum rule says all sum. So every mission must have some objective, not necessarily one unique objective. So I think that answers your case, does it not?
No, if you have you start your mission and you
Yeah.
set 6 objectives, but then you at the end, in the middle of the way, you decide to drop 2. You are not going to pursue those. You never start, you never pursue those.
Okay, but still, you are pursuing at least one. That's all that's needed for the all sum rule. It doesn't say every mission pursues every objective.
But that project executes it. Not all projects necessarily have to execute the mission.
Which is why I'm questioning whether that satisfies the all sum rule. But I think, to be fair, it depends how they understand project and mission. And I tried to tease out their definitions. And we did get some way towards understanding why they would formulate it in this way. But it's still a problem from the perspective of somebody trying to use this from the outside. And remember, the telephone network is the key. An ontology is designed to help people communicate. So you should be always aware of the way the generality of people use specific terms. I think this is worse in the case of component. It turns out that human beings are also components, which we will see in a minute. That may be fine with you, but it's not fine. All right, so in order to do justice to the component performs function, we need to distinguish between the component performs process and the process realizes a function. And then the function in BFO terms specifically depends on the component. The function is what's written on the tin. It's what it's supposed to do. And the process is what realizes the function. Every component performs some process. It's not even the case that every process realizes some function, but if we have a component which is well designed, then there will be some function that this process is supposed to realize. You insert process here in order to do justice to the fact that some components may be sitting in the warehouse forever. And when the function fails, then when the component fails, its function still exists. So if it becomes rusty or it was designed to do a certain thing, that's what it's supposed to do. That's its function. And it's still its function even if it fails, provided other instances of the same type succeed. We still know that this component has this function. All right, and specifically depends on is one of the relations in BFO. So a quality, your color, your skin color, or your height, or your temperature, depend specifically on you. They don't depend on me. So I cannot have your temperature. I can just have an exactly similar temperature. And the little blobs down here are instances. So that's Plato here. Plato is an instance of the kind thing. And now some qualities can be patterns. For instance, the quality of air pressure in this room is a pattern distributed across all the molecules in this room. And BFO distinguishes between two kinds of specifically dependent continuants. On the one hand, there are realizables, such as functions, roles, tendencies, potentials, habits, which you can have without realizing, but they are realizable. And then qualities, which you just have. You don't need to do anything in order to realize them. So you have your height. It's not a realizable quality. Where you have your habit of scratching itches, and that is realizable even if you never realize it for a long period. And every realizable then goes hand in hand with a kind of process of realization, which in the case in point would be scratching. And then we have another specific dependence relation between the realization process and the realizable function or role or disposition. So, it's the quality of my hair to be grey or white. You have a role of being auditor of this lecture just at the moment, but you can lose that role just by walking out of the room or by falling asleep or by deliberately not listening. I have a disposition to fidget with my nose and to say and I have a capability to speak English and to type, and my hands have a certain, I don't have any functions. Organisms generally don't have functions unless they've been designed for certain purposes, like bacteria. But my hands have a function and functions, and all of these are realizable. And of course, machines have functions, components have functions. The role of this room is to serve as a lecture hall. The disposition of this bulb here is to get hot. The capability of this room is to have its temperature adjusted. It's not its function. It's a capability. And it will be important later when we're talking about systems to distinguish between functions and capabilities. And then the function of that heater over there is to heat. So we have roles, dispositions, capabilities, and functions. Roles are typically socially ascribed. So the role of being an auditor in this lecture is a function of how we're divided up into different groups by the social compacts which we tacitly have agreed to. But these things are all physics-based. So every disposition is based upon, for instance, the disposition of my hair to go whiter still is based on the physics of my hair. And my capability to speak Greek, which I do not have, I just did this just for John's sake, is based on the physics of my brain, and so on. And the function of the pump, of the heart to pump, is based on the physics of the heart. So these things are physics-based. All right. So and every function goes hand in hand with a functioning. So you realize the function of to pump by pumping, and so on. Some functions are realized continuously. So a fence, for instance. And some functions are realized occasionally. So a gun would be an example. And some functions are realized only very, 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 very not often. And the sperm is a good example of that. Most sperm never get to realize their function. All right, so all of these are realizables, all of these are realizations. And that brings us back again to the Jet Propulsion Lab Ontology. So this is a wider view now. First of all, we see that components are more than just hardware components. So hardware components are a special kind of component. That solves some of the problems I referred to earlier. Although, as I say, we're not going to be very pleased when we see what the other kinds of components might be. And then we have flight hardware component. I'm not sure what the mass is doing here, but we have solar panel, main engine, antenna, reflector, and I don't know what that is either. Feed horn. I don't know what the feed horn is, but it sounds interesting. And the arrow with the white tip, this is all ISA. And then the other kinds of relations, which are marked with the red circles, are arrows with the black tip. And so we've seen most of those. In fact, we've seen all of the ones here. Okay, so this is all, it's beginning to be more intelligible as we go forward. Yes?
So, just read that there.
Yeah, that comes from them. I left it there as a piece. That's them. That's the Jet Propulsion Lab.
So the ontology is an agreement on usage rather than dictionary. Is that a fundamental belief of BFO in that?
I think it is something which most ontologists, including myself, would accept, but I think there are more important features of an ontology. First of all, an ontology should be an agreement on usage which supports computational enhancement of data. And if you have an agreement on usage but you can't use it to compute, then you've got the wrong kind of agreement on usage.
Okay, so this is my question.
And then I would say that also people like me would believe that the agreement has to be very welcoming to people who weren't in the room when the original agreement was made. In other words, it shouldn't conflict with already existing agreements which might be captured in dictionaries. So there shouldn't be too great a gap between the agreement on usage and the dictionary.
That's what I was going to say. Like, how could an ontology not imply a definition? Much.
Yeah, so
if
the
it was
big,
well made,
yeah,
it must do that.
The big problem here has to do with dictionaries. So dictionaries are made for human use, and dictionaries don't care about circularity, for instance. Ontology should never use circular definitions, but dictionaries are full of circular definitions. They reassure people. So, and sometimes you have circularity at the second remove. So this is not a dictionary, but it is an example. The Larousse Encyclopédique, Larousse Gastronomique. It's a dictionary for gastronomy, for gourmets or for gastronomes. Has an entry for lion meat, which says tastes slightly better than tiger meat. And it has an entry for tiger meat, which says tastes slightly worse than lion meat. Now, at least it's not contradictory, but it is circular. Or anyway, you get the idea.
Have you ever heard anyone use ontologies as a new way of creating definitions?
Yeah, we have people like that, working with the above quite closely. That's the idea. We would create definitions using a computationally useful structured protocol so that the definitions are easier to produce and also produced in a way which makes them all work well together and avoid circularity.
Do you have any examples of that or anywhere you could find that?
If you Google Selja, S-E-L-J-A, Sepella, with S-E-P-A-L-L-A, you will find examples. Okay, so we've seen already that we need to cut apart two layers in the idea of performance. One is having a function, and one is having that function realized, in other words, performing the function. And the gene ontology has a sub-ontology, which we already recognize, called molecular function. But the way in which the gene ontology community understands molecular function very often runs together having a function with performing the function. And this corresponds to a usage in biology of the term, of the phrase has function. Sometimes it means has this function in the sense that in the right environment they would do that thing, but sometimes it means switched on so that they are actually executing it. And if you don't make a distinction between having the function in the underlying sense of being available to perform that function when needed, and having the function in the sense of actually performing it, then you will not be able to cope with all of the cases which you meet in biological data, as the gene ontology community officially recognizes, but they don't always actually remember. This is a case of requirements versus actual realization. All right. Now we come back to components, and it turns out that when you ask them, they have, in addition to hardware component, also human component. And one human component is person, and another human component is organization. So all of these projects, which have project teams and team leaders and so forth, which execute parts of the mission, the teams and the team leaders are all components. Now, as I say, this is understandable. They're systems engineers. They're interested in that big system which is executing the Mars mission, and which has the objective of taking human beings to Mars. Then there are various components in that big system, some of which are human beings, some of which are organizations, and some of which are hardware. It's just that that's not the way the word component is used by normal people who get to see this and may need to use it. And now let me talk a little bit about role. In order to understand human components, and in order to understand organizations, and in order to understand team leaders and so forth, we need to understand roles. And the first thing to be said is that you have a role for a certain time because of some social ascription, imposition, disagreement. The second thing to be said is that once you get that role, you will very quickly gain associated dispositions. So once you are made team leader, even if this is your first role as team leader, you're very quickly going to get certain dispositions, which means your brain will be changed physically, associated with directing people's behavior. And so roles, we say, are an externally grounded realizable entity, which means they are grounded not in the physics of the bearer, but in the social network in which the bearer operates. Dispositions are internally grounded realizable entities. What that means is that to have the dispositions, and dispositions are things like beliefs, habits, skills, competencies, and so forth. To have one of those things, you have to have the appropriate physics. Your brain has to have been trained, or has to have developed in the right way. And now, some dispositions are beneficial. And we call those dispositions capabilities. And this applies not just to dispositions of human beings, but also dispositions of equipment. So I have the disposition to scratch when I'm speaking. That's not a capability. Why? Because it doesn't bring me any benefit. I have the disposition to say, that's not a capability. There's no way of saying well or less well. So, the official definition of capability is something like this. A capability is a disposition whose realization can be graded so that it's well or less well, realized well or realized less well. And then this realization brings benefits either to the bearer or the bearer's group, the bearer's child, for instance, or to the owner or user of the bearer, where we're dealing with the dispositions of an artifact. So the reason why my car's ability to drive through snow, sorry, let me get this right. My car has a disposition to grip snow so that it drives even in snowy weather. That's a capability because it brings benefits, not to the car, but to me, or to anyone driving the car. And it's a disposition which can be graded on a scale. So some cars do it better than others. And that means that that particular disposition is a capability. A disposition on the part of a normal human being to kill other human beings without any feelings of conscience is not a capability. It would be regarded as a disease. Unless you're in the military, in certain or in the mafia. In the mafia, that is a capability. In certain teams of the mafia. So bringing benefit is a contextual thing. And that means that a thing which is counted as a disability in one context may be counted as a capability in another. Now all of this is important for systems, of course, because systems are full of functioning components, but also full of components which have other capabilities. For instance, the capability to be still working when you're on your way to, or when you're already on Mars.
Barry?
Yes?
So all dispositions all dispositions have capabilities.
Every capability is a disposition,
Yes.
and every function is a capability. Functions are the capabilities we design things for. Capabilities are capabilities which come along for the ride. So we didn't design, we didn't build cars in order to grip snow. Some cars don't grip snow at all. We design cars. Cars have the function to transport people. Some of them have the capability to transport people even on snow and icy roads. And that's the difference between functions and capability. Functions are capabilities. Capability to transport people is a capability, but it's also the function of a car. A drone may have the function of moving when remotely steered through the air and have the capability of being able to transport people if they hang on very carefully.
Yeah. So what happens when the capability develops new because of the environmental changes?
That's fine. But many capabilities are acquired. The capability to speak Greek, you can acquire it. Even you, actually.
But in that case, you have the ability to animate. But you know what I'm getting? So how do you deal, how you represent those capabilities that not necessarily are directly tied into a disposition?
Oh, but they are. So
Okay.
as soon as you have the capability to speak Greek, you have the disposition to speak Greek, however weakly. The question is whether you have the disposition to learn to speak Greek. And it's an interesting question.
So no example for us, not all disposition for a human you have to have it when you're born.
Yeah, that's right. If you're born in Greece with Greek parents, you probably have the disposition to speak Greek or learn Greek.
I have a question.
Yeah.
One of the things I remember in engineering education in terms of system engineering is that question one kind of in system engineering is regarding the system boundaries.
Yep.
So I'm wondering, can you approach the formalization of a system engineering ontology absent what I'll call, from what I've seen here, the definition of the role? The role has to do with sort of purpose, and purpose maybe sets boundaries in some way. So
Yes,
So do you need? So if you're doing a system, if you're doing an ontology for, let's say, an application, so to say, is job one setting down the role of the system, so that, going back to that idea, that the boundaries are formed.
So I'm going to talk about system boundaries later. I will not make the point that you just made, but I will make it now. Engineered systems certainly are created in order to achieve certain objectives. Those objectives will determine the system boundaries. However, the main point I will be making later on is that practically every engineered system is going to exist in an environment which will contain systems itself, and some of which will include the system that you've engineered. And so the examples I have are all biological, but you can understand it. Your system for creating a really successful Italian food experience by creating a chain of restaurants has a boundary, which includes the buildings and the headquarters and the kitchens and so on. But there are fields in Italy where they grow tomatoes on the basis of another system which you need to rely on. And so your system has a boundary, but it's part of a system, a larger system of systems without which it couldn't work. And that will come later. All right, so, and now I just wanted to say that there are people who are trying to use data about the capabilities of equipment, components, factory, machines, and so forth, in order to create the stepping stone for an ontology of capabilities relevant to manufacturing. And Fahad Amari, the principal author of this, is working with us to re-engineer his ontologies to be Buffo-conformant. And so the work on defining capabilities derives from collaborations with him. Now let's talk a little bit about functions. A function is a capability. It exists in virtue of the bearer's physical makeup because all capabilities are based on the physics of the bearer because they're all dispositions. And, this is the important thing, this physical makeup is something the bearer has because it, the bearer, came into being either through evolution or through design to realize processes of a certain kind. So we were not created either through evolution or through design to realize processes of a certain kind. We are not here to breathe. We are not here to do ontology. Well, some of us nearly are here to do ontology. We're not here to wear clothes. We're not here to design buildings. We're here. It's an accident that we're here. But this laptop is here to execute Turing machine conformant programs or something like that. And this piece of paper is here to serve as a basis for people writing or printing on it. So all artifacts have functions because all artifacts were designed. And that's what the function is for an artifact. It's that which the artifact was designed to do. And some biological things have functions too, which is namely those biological things such as organs and systems in the body, the digestive system, they exist because evolution created things to do that thing. So parts of organisms can have functions, but whole organisms typically do not have functions. Now, artifacts have functions. They also have capabilities to function at higher temperatures, to function continuously, to function even on the way to Mars, and so forth, or to function more safely. They are capabilities. Capabilities are dispositions that entities have which bring benefits, but which only in some cases function. In other cases, they just come along for the ride. So we've seen that, and now this is an idea for a definition of engineered system. So we said that an engineered system is more than just one object. It's an engineered artifact consisting of several component artifacts, A1 to AM. And each of these component artifacts has a function, or multiple functions conceivably, so F1 to Fn, and a series of capabilities, C1 to CP. And now the system has some function F to get to Mars, or something like that, and exists because something was needed to realize the function F. That's why the Mars mission system exists, because something was needed to get to Mars. Now, and this function is realized through the coordinated realization of all of these other functions together with their capabilities. Now, that I don't know whether that's a useful definition, but there is a discipline called capabilities engineering, which is trying to understand how enterprises can operate better by solving equations like this. So you have an enterprise, you have the capabilities of all the equipment, all the people, including the leaders of teams and so forth. You have a job, and you want to know how best to realize that job, get to Mars, build a new mousetrap, or whatever it might be, given the capabilities that you have. And in order to do that calculation, you have to have a formal way of describing the capabilities of all the people and equipment in your factory. So, now we'll go back to, well, actually, no, let's pause for questions now. Do we have lunch? You don't know, but you can speak anyway. Can you pass him the microphone?
Barry, can you go back that one?
Oh, sorry.
Oh, yeah.
No, since you have it, you might as well.
That's okay.
I was wondering if you could go back to your definition of role. Like I see on the handout that it does not fit under function or disposition?
Yeah, that's right.
Side by side?
It's a realizable. So there are two kinds of realizables, dispositions and roles.
Yeah, so I'm wondering why isn't a role defined in terms of functions that you require? Or being
so-
socially acceptable?
Yeah. So, first of all, the word function just doesn't sound right in that context. It doesn't. People say, "Oh, her function is to clean up the bedding," or "His function is to clean up the toilet." It doesn't. Or my function is to talk about ontology. It doesn't seem right. It's my habit to talk about ontology. It's her job to clean the bedding. It's his job to clean the toilet. But that's not the function. Function has to be something which is much more profound than that. Your function, or something's function, is the reason for that something's existence.
Do roles have functions? And then-
No, not according to BFO. And this is one of the ways in which following BFO gives you you puts you in a good position, because you always have answers to questions like that. So we sometimes talk as if other things have roles, but according to BFO, only material entities have roles. It's possible that some kinds of information entities have roles, but we haven't documented that to the
Is it
contentment.
synonymous with purpose?
Hmm?
Is it synonymous
I am
with
working with the idea that function and purpose are interchangeable, and this
No, I
would
meant
mean
role.
that.
I meant
Oh
role.
no, because the function is much more. Purpose is much more like function. So let's suppose you create a new subdivision within your organization. The purpose of that subdivision is to manage transport for the organization. That sounds very much like function to me. Since we already have the word function in VFO, it's tempting to say, well, let's give divisions of organizations functions. Let's recognize those aspects of organization to be functions. And I believe that the ST for SE ontology I've been showing gives human beings, gives organizations anyway, purposes or objectives.
So at the meta level, when you were saying S has F,
Yeah.
right? System has a function.
Yeah.
So
Remember that we're talking about aggregate engineered artifacts. I think it could be true also of biological systems. Your digestive system has a function, namely to digest food, and it has certain capabilities to digest licorice. And
I'm okay with all this.
Yeah.
The word I'm struggling with is role.
yes, so role is things like lawyer, nurse, teacher, debtor, bankrupt, husband. They are not there such that you can get them in an instant without changing at all. Just somebody signs a paper somewhere and you become professor. And then once you realize you're a professor, you start teaching and you get new habits. And then you have a disposition. The role is a paper matter. It's a formality. It's a very important formality because it gives you things like salary. But it's not a physical matter. It's a matter of social decision. It's a fiat matter. Yep.
In your ESA relationship of a human component, you have two parts. One is human, the other is organization. How do you define organization in that context?
So remember that came from the Jet Propulsion Lab. So BFO does not have the term organization. It doesn't have person either. It just has object, fiat object part, and object aggregate. And my own view, and I think I'm going to defend this in Pisces in the afternoon, is that an organization is an object aggregate. It's an aggregate of people. Now those people have certain capabilities, and that they belong to divisions of the organization, which gives them certain. Let me be very careful. duties, let's say. But the organization itself is just the aggregate of people. Don't say just. So delete the just. An organization is an aggregate of people with certain capabilities and roles. Differential. So one of them is leader.
Yeah, because if you define organization also with more than just an aggregate of people, equipments and stuff, right?
So you don't need the equipment stuff. The organization probably goes through, if it's a long-standing organization, it probably goes through multiple generations of equipment. So you wouldn't say this computer is part of IBM. You'd say this computer belongs to IBM.
Okay.
Part of the property of IBM. It's not part of IBM. Well, you would say that the CEO is part of IBM. And you, if you work for IBM, you would say probably I am part of IBM. Yep.
So going back to this question of...
Can we pass the microphone back?
Just going back to this question of role. So since role seems to be defined by social mechanisms,
Yep.
is it fair to say that these are only applicable to objects that exist in some sort of social context? Is there an example of role for like a material system?
Yeah, so this is also something which we have argued about. So an example of a role in the biological world might be something like being a messenger or being a transport molecule. And where you have directionality, in other words, where you have an initiator and a passive recipient, that looks more like a role relation than it looks like a disposition relation. However, the biologists that we work with do not like the idea that there are roles in the biological realm. So we say roles are typically a matter of the social framework or the social imputations or agreements that people make. Now, there are many biological entities which have roles because people give them those roles. Food is a role, for instance. In some cultures, given material entities are food, and in other cultures they are not food at all, because they're for one reason or another. And similarly, being a drug is a role matter. And certainly being a drug approved by the FDA is a matter of role. And there are other such cases also. Being a property line marker is a role held by a lump of stone.
So you mentioned that in BFO, or specifically with roles, that you don't get it automatically.
Yeah.
There's a process by which you become a professor, by
Yeah.
which you get a role. How does BFO, from a data standpoint, keep track of a process? How does something change? Like, I'm a student here, and I go home, I'm a dad, and then in the future I'll be maybe a grandfather. Like that.
Yeah, we have labels for the corresponding roles, and you have those corresponding roles at different times, in different phases of your life, and you exercise those roles at different times and in different contexts. So it gives you the way that one thing which some ontologies did wrong was to confuse roles with classes. So to say that being a father is like being a mammal, or to say that being a nurse is like being a mammal. And it's not, because if you're a mammal, you have to be a mammal. It's something which is part of your essence. If you're a nurse, you don't have to be a nurse. In fact, all roles are optional.
Are you going to give examples later on of BFO from a system data standpoint, what that looks like?
No. No, now I see there is one. So let's have 4 more minutes of talk, and then we will have...
David had a question.
Yes, over there.
I had a question about this first bullet point.
Here it is, where something like an assembly line that may have
Yeah.
important human components. You have humans on the
Yeah.
line assembling the product. In my mind, I would think of the engineering system as including these humans. But this bullet point would seem to rule that out. So I'm wondering if I'm misunderstanding what it is.
No. So first of all, get with the program. All assembly lines are going to be completely robot-driven within the next month. But you're right that many things are still human-driven or are still such as to involve human action. And I think that there is a very serious need and a very serious goal of working out how we capture in a controlled vocabulary the capabilities of human beings. And they do this to some degree in medicine. So you have all these exams that people have to pass, and they have to fill in forms, and they are being observed by other people as to how they perform. And that should be being done more and more in other areas also. People hate it. The idea is that to do that properly, we would need properly calibrated systems for all the dimensions along which people's capabilities are being realized. And where there is a need for that, there is already informal, or there are already informal mechanisms. When you're hiring people, you use assays to measure their capabilities, which will be typically very informal. And the more we can get those assays to be more formalized, the better. And I believe that the one element of that will be an ontology of capabilities. And that's being done already within the machine realm. It's just not being done very much in the human realm, except in baseball and football, where it really matters.
Are we calling humans engineered artifacts?
No, on the contrary.
Okay, so humans are never a part of the aggregate, which is the engineering system. So humans are always
No, on the contrary. Humans will be part of every system. Even if the system involves assembly lines, which are completely automated, there will still be humans there to determine all kinds of questions. For instance, when the assembly line fails, that there will always be humans in the loop. Humans determine the objectives. Humans determine the things like prices and so forth.